In this video, we are going to derive the three kinematic equations. Suppose an object is moving with velocity v0 and after some time it has velocity v. Now the acceleration of the object can be written as the change in velocity over the change in the time. So v minus v0 divided by t minus 0. So if you rearrange this equation, you will get v equals v0 plus at. This is equation 1. The second equation relates two quantities, displacement and velocity. To derive the second equation, let's consider this graph. This is velocity time graph. Initially, the object has velocity v0, and after some time t, it has the velocity v. Now to derive this equation 2, we are going to use the fact that the area under the curve will give you the displacement. So the area under the curve can be divided into two areas, the area of the triangle and the area of the rectangle. So find the area of the triangle, find the area of the rectangle and add them to get the displacement of the object. So we know area of the triangle can be calculated as half BH. Okay, base is actually this AC, that is nothing but time t, and height is v minus v0, that is BC. So how? From here to here the length is v, and from here to here it is v0. So you will have BC as v minus v0. So we found this area of the triangle. Now to find the area of this rectangle, we know it is length into breadth. So here let this be L and let this be B, this length. So this B is T and the length is B0. So you will have the area of the rectangle also. So add these two, you will get the displacement of the object. And from equation 1, we know v minus v0 is at. So substitute it here and you will get x equals v0t plus half at squared. So this is equation 2. Now equation 2 has another form. Just start with this equation. This is the area of the triangle and this is the area of the rectangle. And now I am just going to expand this one as half vt minus half v0t plus the third term. And if you simplify these two, you will get this term here. And if you observe, we can get x equals v plus v0 by 2. This is called as the average velocity v bar. So v bar is v plus v0 by 2. And this average velocity you can find for constant accelerations only. And now we are going to do equation 3. This gives the squares of the velocities. Let's start with this equation. This is from equation 2. We know x equals v bar t, and v bar we know that it is average velocity, and v minus v0 by a, that is from this equation, from equation 1, we know v equals v0 plus at. So from there, I can write t equals v minus v0 by a. So instead of t, I substituted this, and this is the average velocity v bar, and using a plus b into a minus b is equals a squared minus b squared formula, a squared minus b squared, which equals a plus b into a minus b. Use that and then you will get v squared minus u0 squared divided by 2a. And this 2a goes to this side and it will become 2ax. And if you rearrange, you will get v squared equals v0 squared plus 2ax. And this is equation 3. And that's it. Thank you.